Hello everyone, my name is Pramod Kumar Nayak. I am from Ajimas Technologies Private Limited, Bangalore. Welcome you all to this course on digital signal processing. So digital signal processing is a branch of engineering that in the space of few decades have enabled unprecedented levels of intrapersonal communication and on-demand entertainment. By reworking the principles of electronics, telecommunication and computer science to an unified paradigm of, say, DSP is the heart of digital revolution. It might be in terms of using DVDs, MP3 players, mobile phones or any countless devices which are currently available in market. Our goal for the students in this course would be they learn the basic fundamentals of digital signal processing from ground up. Starting from the basic definition of discrete time, impulse response, sampling, going forward, concepts of Fourier analysis, filter design, interpolation, quantization are being built using the various DSP tools which are available currently in market. So these tools are industry standard packages which would be used in this particular section, and hands-on examples on demonstration would be a routine to bridge the gap between the theory and practice, and also help the students to explore the various projects which would help them in their further careers in terms of placement. To make best of this class, it is recommended that you go through the basics of few mathematical concepts including basic calculus, linear algebra and certain basic programming knowledge is also useful. So let us dive into the digital signal processing concepts. To start off with, we have something called as the concept of sampling theorem. Now this is the first experiment which we cover in terms of the lab experiments which are available in the video syllabus. So what is sampling and what is sampling theorem? So there is a difference between sampling and sampling theorem. Sampling basically deals with converting a continuous signal into discrete. Then what is sampling theorem? Say I have a signal, a continuous signal, and if it satisfies a condition, okay, so if it satisfies a condition, once you convert a signal into discrete and or into a samples, and you are able to obtain back the original signals using the same sample, is called as sampling theorem, and it has a condition that has to be satisfied. So what is that condition? Let us go in depth into it. So we'd be using MATLAB to verify the sampling theorem. So what we'd be doing is generate a sinusoidal wave or a sine wave of 1 kilohertz, calculate the frequency and verify the sampling theorem and show the output of three conditions, that is undersampled, oversampled, right sampled cases. So the theory behind sampling theorem is a process of converting a continuous time signal into a discrete time signal. In sampling, the values of continuous time signal is recorded at discrete interval of time, usually equidistant. The number of samples taken in 1 second is called as sample rate, or it is also called as sampling rate, which we are aware of. So that was the theoretical background of it. Now sampling is described by the relation x of n is equal to x a of n into n, where n varies from minus infinity to plus infinity, where x of n is a discrete signal obtained by sampling the analog signal for every t seconds. So I can say sampling frequency is given by f of s is equal to 1 divided by t, and it is also known as sampling frequency. The sampling theorem is also stated as a band limited signal can be reconstructed exactly if it is sampled at the rate twice the maximum sample frequency component in it. So this is what is the condition of sampling theorem which I was mentioning in. Assume a band limit signal x of n is equal to a sine omega t, where omega is equal to 2 pi f. So I can write it as a is equal to 2 or sine 2 pi f t with the frequency component omega. The theorem says that for a good reconstruction of original signal or the time signal, the sampling frequency must be at least 2 omega. This frequency is known as Nyquist rate. Please make a note of this. So moving further, this is the first output. You can see that's a continuous signal, and we can see that whenever f of s is 10 times the f, that is your frequency, it is called as oversampling condition. And you can see when f of s is equal to 2f, we say that it is the Nyquist frequency, where you can see the sampling associated to it. The last graph here, you can see that f of s is equal to 1.5 times of f, which is the undersampling condition. So this is the output which we are looking forward. So let's go further and analyze the same by MATLAB software and write a program to achieve these conditions. See you in the next section.